Okay, so here's another example for the week for tutorial. And in this example, we have 100 kilogram crate C rest on the floor of the elevator, for which the coefficient of the static friction is given as zero point 0.4. So we will start from the information we know. We need to remind what will be the largest angular acceleration alpha, starting from the rest, which the parallel links AB and the DE can have without causing the crate to slip and no tipping occurs. So once again, this is the scenario. That's the box we're talking about. It's 100 kilogram. Center of gravity is going to be in the middle, going downward for the weight. Of course, we are going to have a friction force. It's going to be at the bottom here, and is going to opposing the slipping. So usually that will go up. This will be inclined in this direction. So the friction force should resist that, and that's what you can see here. Friction force is going to be equal to normal force multiplied by the coefficient of friction. So the axis of the rotation is going to be linked between the point here. Okay, so this 30-degree because we're going to do analysis for this one. So the center of the gravity to the axis of rotation is going to have the tangential acceleration to be 100 times the acceleration. So actually, we're just saying that I need to sketch the free body diagram and the kinetic diagram and to understand how the thing is going to be shown. So the solution given to you was first we need to find the normal acceleration at the point G, which is going to be the same one as the point C. When I want to say G and C, you can read that from here. This is the point C, and that's the point G in the middle. Okay, the tangential acceleration for both points and free body diagram are to be drawn first. And with the kinetic diagram, the sigma of the force to the x-axis is going to be equal to the mass multiplied by the acceleration x, and the forces in the y direction is going to be equal to the mass multiplied by the acceleration y. By solving, we will find that the normal force is going to be 1.28 kilonewton, and the alpha accordingly will be equal to 5.89 meter per second square. Remember that we're starting from rest, so some of the parameters will be equal to 0. So we coming to the diagram once again. That's what we're going to have. The G point is going to be in the middle. That's the box, and the friction force will be somewhere at the A. Normal force is going to be upward. The friction force is going in that direction to prevent the box going to the left. The weight is going downward. Now here you can see that this will be inclined as the normal and the tangential acceleration. This will depend, of course, on the direction of the links we have here. These are the links. So when we're going to rotate that, the omega of that link will be moving this one up. So the velocity should be found here is going to be the same as the one we have on the box. So, however, we're going to go back to this one. So I need to find the normal and the tangential one. Then again, to change them to the x direction and the y direction and make the analysis to the other side. These are the x and y. This is normal and tangential, which are parallel to the length that we have for the carrier. So we know that the coefficient of friction is 0.4, the mass is 100 kilograms, the omega is 0 radian per second, because we said it's starting from the rest. That means the omega, it was 0 at that instant. Now the unknown is going to be the alpha, and we have the three equations. The moments are 0. The sigma of the forces in the free body diagram is equal to the forces we have in the kinetic diagram. So in the x-axis, going to be equal to the m multiplied by the acceleration in the x-axis, and sigma of the force to the y-axis is equal to the mass multiplied by the acceleration to the y-axis. Now we come to the calculation. That's the equation we have for the normal, which is going to be simply equal to the acceleration dn, where it's going to be equal to the omega squared multiplied by the r a to b. Okay, so definitely omega is 0, so this one will be equal to 0. For the tangential one, it's going to be alpha multiplied by the RBA. And this one is equal to 1. The length of the link is 1. So definitely the alpha is going to be multiplied by 1 and is going to be equal to alpha. So now that's telling you what was the 100 multiplied by alpha that we had here, which is 100 kilogram multiplied by the tangential acceleration. Now we are going to analyze these two components to an x and y. So this was normal and tangential. We're going to change it to x and y. So we need to do some trigonometry for the shape we have. And actually, I need once again to go back to the previous page just to, I'll try to bring this one in. But anyway, that 30, that means this one is going to be 60. Anyway, if I would like to take this one to the x direction, this will be equal to alpha multiplied by the cosine of 30 and sine of 30 for the y direction. Okay, so alpha cosine of 30 for the x-axis or alpha multiplied by the sine of 30 to the y-axis. You may see something here like the 60, but anyway, it's going to be the same. So once again, for this side is going to be 0 because you said that the AGN is 0. We're going to have the cosine and the sine as I mentioned. The cosine for the x-axis, the sine for the y-axis. So the equation we're going to have is going to be that the acceleration to the x direction is going to be alpha cosine 30 and the alpha sine 30 for the y. If I can show you that on the sketch once again, that's my x-axis and that's my y-axis, and that's the 30-degree we have. So to take this one down, we multiply by cosine, and we take it up, we multiply by the sine. Now we continue with the work here, and now the forces to the x-axis. We had the friction force and the free body diagram. Here we're going to have the mass multiplied by the acceleration to the x direction, which is going to be 100 alpha multiplied by the cosine of 30. 100 times alpha multiplied by the cosine of 30. That will be the first relation. Now the F friction force is equal to the coefficient of friction multiplied by the NC. Now here we have two unknowns, so I can now solve for this one. Let's go back to the other relation. Of course, from this one, I can find a relation between the alpha and this, the normal force. Okay, so I can find a relation between both. Then I'm going to take it and put it to the y direction angle. The weight that's going downward, negative value, plus the NC, which is unknown, and that will be equal to the mass multiplied by the acceleration in the y direction. So again, I get to have the alpha is unknown. And I will come out with the equation saying that the NC now is going to be equal to 50 alpha plus 9.81. Now we have two equations, 1 and 2. I can substitute 2 in 1 or 1 in 2, and then I will get the answer for the alpha or the NC. So simply solving 1 and 2, and we get that the alpha is going to be equal to 5.89. That's a request. And of course, if you know the alpha, we can find the value for the numerical the normal force. So it's simple, few steps. It's much easier than the solution we had on the solution sheet. And once again, we're going to discuss that more detail in the class.